Hello, welcome to the second video on the volume of rotation and the cylindrical shells method. So this is chapter 6, section 3. We did the first example on the first video. We're going to do the second example on the second video. So here's the example. They give us the region which is bounded by the function y equals 2x squared minus x cubed and y equals 0, and then that region will revolve about the y-axis, and the question is to use the shell method to find the volume of rotation. So first we graph the region. When you sketch the curve y equals 2x squared minus x to the third, it'll give you this graph, and then the y equals 0 is the x-axis. So basically we get this region, and the rotation is respect to the y-axis, so we put those curved arrows to mark the rotation. And within the region we selected a point x, and then from that x we trace it to the curve, and then which is f of x, which is 2x squared minus x to the third, and then from there we draw a rectangle, which is the cross section when you're using the shell method. So the cross section in terms of the shell method is a rectangle, and this rectangle must be parallel to the line of rotation, not perpendicular but parallel. Since the line of rotation is the y-axis, so this rectangle will be standing up like that. And so basically the height of the rectangle is the height of the cylindrical shells. So therefore we're going to call the height h of x, which is the function itself, 2x squared minus x to the third. Now we need to find the radius. The radius of the shell is the distance from x to the line of rotation. The distance of x to the line of rotation is just x minus 0, which is x. So we pretty much got everything, except that we need to, because of this x, everything must be expressed in terms of x. So we're pretty good with the function. Now we need, what we need is the limit of integration. So we know that this curve is basically touching the x-axis at 0. At least we know one limit. But what is the other point here? So these are the 2 points are what we call the X-intercept. So we can just go to the function and then find the X-intercept by setting y equals 0 and then solve for x. So when you set y equals 0, you get to 2x squared minus x cubed equals 0. You factor out x squared, you get x squared times quantity 2 minus x equals 0. You set x equals 0, which will give you x equals 0. X squared equals 0, give you x equals 0. 2 minus x equals 0, so x equals 2. So that gives us our the limits of integration, which is 0 and 2. So now we go down and copy what we have so far. The radius is basically x. The height is 2x squared minus x cubed. And so we go to the volume. The volume is the integral from a to b of 2 pi times shell radius, and then times the shell height, and then dx. So we know the radius is x, so you plug in x here, and the height is 2x squared minus x to the third, so you replace it over here, and then the limit of integration we just got from 0 to 2. So before you integrate this, you must distribute x. So x times 2x squared gives you 2x cubed, minus x times x cubed gives you x to the fourth. So you find the antiderivative of 2x cubed, which is 2x to the fourth divided by 4, minus the antiderivative of x to the fourth is x to the fifth over 5. And then we're going to evaluate this expression n0 and 2. So first we simplify. 2 here, and then when you plug in 2 for x, you get 2 to the 4th over 2 minus 2 to the 5th over 5, and then you put this within parentheses, minus, you open parentheses, then you evaluate this expression at x equals 0, so you get the 0 minus 0, which is 0. And so this is 16 divided by 2 is 8. 2 to the 5th is 32 over 5, and it times 2 pi. So you find the common denominator, which is 5. So 5 times 8 is 40 minus 32 over 5, which is give us 8 over 5. And then times 2 give us 16 pi over 5. So that's the volume using the cylindrical shell method. The third example is another example. We have the region is described as y equals square root of x, x equals 0, x equals 1, and the x-axis. And the rotation is about the x-axis. So basically, when you graph y equals the square root of x, this is what you have. X equals 0 is just that dot, and then x equals 1 is this vertical line, and the x-axis. So that gives us this region, and this is the rotation is respect to the x-axis. So we mark the curve arrows for rotation. So the point is, because the rotation is the line of rotation is horizontal, that means that the cross-section rectangle will also be horizontal. So we go and pick a y because the cross-section is horizontal. So this point x will, this point y will, we're going to use it to graph the rectangle. Okay. So the point y comes here, and from this point y we graph our rectangle. This cross-section rectangle is parallel to the line of rotation. So that means the height of, so when you, the point is, when you rotate this rectangle with respect to the x-axis, you're going to get a cylindrical shells like this one here. So you can see here the radius is going to be the distance from this point y to the x-axis. So basically it's going to be y minus 0, which is y. That'll be the radius. The height is the height of the rectangle, but then you're going to go from right to left. So this line is x equals 1. Now this function was given as a function of x. Because of this y, we have to change this function in terms of y so that it becomes a function of y. To do it, we have to square both sides. So when you square y, you get y squared. You square square root of x, you get x. So this function must be changed as x equals y squared. So to find the height, we're going to go from right to left. So this point to the right is x equals 1. That point to the left is x equals y squared. So that means the height is going to be 1 minus y squared. Okay, so you get h of y equals 1 minus y squared. So now we got everything. Because everything is going to be expressed in terms of y, we need also limit of integration. But we know at this point, when x is 1, if you plug in 1 for x, you get y equals 1 also. So this point is y equals 1, and at that point is going to be y equals 0. So our limit of integration is going to be, we're going to integrate from 0 to 1. Okay, so write down shell radius is y, shell height is 1 minus y squared. The volume is going to be the integral from c to d of 2 pi times radius times height dy. The radius is y, the height is 1 minus y squared. So we have this integral. To do it, again, we're going to distribute y to 1 and to y squared. We get y minus y cubed. And then 2 pi is a constant. we can just find the antiderivative of y, which is y squared over 2 minus y cube. The antiderivative of y cube is y to the 4th over 4. Plug in 0 and 1. So you get, when you plug in 1 for y into the expression, you get to 1 over 2 minus 1 over 4. You plug in 0, it gives you 0 minus 0, which is 0. So you end up with 1 over 4 times a 2 pi. Simplify 2 to get pi over 2. So that's the end of the third example. Thank you very much.